Now let's look at the discriminant. And first we're going to look at the discriminant using only real numbers. And the real question that we're asking here is how many solutions are there to a quadratic? So how many solutions does the quadratic equation have? And this is actually the same question as how many x-intercepts does the quadratic equation have? And what we're going to ask is, for now we're just going to use real numbers, so we're going to ask how many real solutions does the quadratic equation have. And if you need to do it with imaginary numbers, there's a follow-up video that uses that. And here's the rule that we're going to use. The rule that we're going to use is we're going to take b squared minus 4ac, right? And this is for a quadratic written in a standard form, so the standard form being y is equal to ax squared plus bx plus c. So when it's written in this form, we're going to call the discriminant b squared minus 4ac. And the rules are going to be this: if b squared minus 4ac is positive, then that means there's two real solutions, or two x-intercepts. If b squared minus 4ac is negative, that means there's no real solutions. And if b squared minus 4ac is equal to 0, we're going to call that one real solution. And it means that it's going to be actually tangent to the x-axis at one point. So these are the three rules. So let's look at a given problem. So the first problem let's look at is how many solutions does y is equal to 2x squared plus 3x minus 5 have? Sometimes it'll be written like this: 2x squared plus 3x minus 5 is equal to 0. Here they might ask you how many x-intercepts there are, and here how many real solutions are there. So what we're going to do is, in this problem, is a is 2, and b is 3, and c is equal to minus 5. So the discriminant is b squared minus 4ac. Let's just plug the numbers in. That's 3 squared minus 4 times 2 times minus 5. Now you have to be real careful here and make sure you do the order of operations correctly. The first thing you're going to do is you're going to do power, so that's 9. And the second thing is you're going to do multiply, so we're going to multiply 4 times 2 and minus 5. That's 20, 40, and it's a negative times a negative, so that's going to be a positive. So that's 8 and 5 is 40, so it's 9 plus 40, which is 49. Since the discriminant is positive, if b squared minus 4ac is positive, that means there's going to be two real solutions. And that's how you use the discriminant. Let's look at another example. If we look at another example, let's look at 3x squared plus 2x plus 7 is equal to 0. In this case, a is 3, and b is 2, and c is 7. The discriminant will be b squared minus 4ac, which is 2 squared minus 4 times 3 times 7. Do the power first, so it's 4 minus 4 times 3 times 7. Then do the multiplying, that's 7 times 4 times 3. That's 21 times 4 is 84. So that's 4 minus 84. And the discriminant is minus 80. Since b squared minus 4ac is a negative number, that means there's no real solutions. If you notice, then what is the discriminant? If you look at the quadratic formula is just minus b plus or minus the square root b squared minus 4ac over 2a. And this is just the discriminant right here. b squared minus 4ac. Let's do one more example. Let's do 3x squared plus 6x plus 3 is equal to 0. All of these presuppose that you're given the problem ax squared plus bx plus c is equal to 0. And if you're not given to it in exactly that form, then just rewrite it thusly. Here a is 3, and b is 6, and c is 3. The discriminant is b squared minus 4ac, which is 6 squared minus 4 times 3 times 3. 6 squared is 36. This is 3 times 3 is 9, 4 times 9 is 36, so you get 36 minus 36. 36 minus 36 is 0. 0 means there is exactly one real solution. That's how you use the discriminant to determine the number of real solutions. If you want to think about what that means graphically, 2 solutions is just 2 x-intercepts. So that's 2 real solutions. No real solutions is a case when you have a parabola which does not cross the x-axis, so that's no real. And 1 real solution is a case actually where you have a parabola which is tangent to the x-axis, so that would be 1 real solution. And that's how you use the discriminant to determine the number of real solutions.